Right, Avogadro's number is the number that's now going to get incorporated into these. So, reminder that this is Avogadro's number. What does Avogadro's number tell us? Yeah? Right, this, yeah. Right, that is the number of particles in a mole. Doesn't matter what I'm dealing with. If it's water, it's that many molecules in a mole. If it's magnesium, it's that many atoms in a mole. It's just like a dozen. A dozen is always 12. It doesn't matter what I'm talking about. Okay, this is the number of particles in one mole. Right, that's what Avogadro's number tells us. Okay, so the question this time is asking how many molecules are in 600 grams of silver nitrate. So what does the question give us? Okay, 600 grams, so it gave us little m, and it told us the material is silver nitrate. This is a -1, that's a +1, so that compound is dropped and swapped correctly. All right, calculate molar mass here. Silver is like 107.87. Plus 1 nitrogen plus 3 oxygens. All right, so 107.87 plus 14.01 plus 48, that's our 3 oxygens. Okay, 169.88 grams per mole. Okay, everybody follow what we've done so far? Okay, the question's asking how many molecules. That's not part of the mole equation. The mole equation calculates number of moles, mass, or molar mass. Those are the only 3 things I can get from it. Okay, right now, what can I use the mole equation to find? Right, might as well do that. It seems like an intermediate step. Okay, so let's look at calculating the number of moles, and then see if we can do anything with that number once we have it. Okay, so we have 600 grams, and the molar mass was 169.88. All right, so I have 3.53 moles. Okay, so far you'd have a mark for your givens. Okay, you'd have a mark for this step, calculating the number of moles. Okay, sometimes I would give a mark for plugging in the numbers, or sorry, sometimes I would give a mark for having that answer there. Okay, so I have the number of moles, and I have Avogadro's number, which tells me the number of molecules in a mole. What can I do with those 2 numbers to find out the number of molecules in 600 grams? Right, you can multiply them together. Okay, in the same way that if somebody asked you how many donuts are in 4 dozen, you would go 4 times 12. Okay, well, I have 3.53 moles, and this is how many are in a mole. If I multiply those 2 numbers, it should tell me how many molecules there are in total. Okay, does everybody follow what we just did there? Okay, if that's the number of molecules in a mole, and this is how many moles I have, multiplying them together should tell me how many I have in total. Okay, so the number of molecules equals 3.53 times Avogadro's number, 6.02 times 10 to the 23. Now, the big question is, how do I put that number into my calculator? Well, let me show you. If you have a TI-83, okay, you will use the EXP, or sorry, the EE button here, okay, which is it's above the comma, so you have to use your second function. If you don't have a TI-83, your calculator either has a button that has 2 capital E's on it, or it has a button that has EXP on it. Okay, that is the button you will use to get the times 10 in there. Right. So if we're doing this on a TI-83, I'll have 3.53, and I'm going to multiply that by Avogadro's number. Avogadro's number always has to be enclosed in brackets when you use it, whether you're dividing by it or multiplying by it. So I'm going to go brackets 6.02. And then for me, I'm going to hit the second function button, and where the comma is. When I do that, it gives me a little e. Well, a little capital E. Okay? But that little e means times 10. Now all I have to do is enter the power. So what number am I putting in next? 23. Okay, so I have 6.02 E23. I have Avogadro's number entered into my calculator. If you don't have a TI, okay, then what you do is you go brackets 6.02, and you hit either your EE button or your EXP button, and then hit 23 and close the brackets. Okay, if you're having trouble with that, call me over and I can show you how to do it. All right, so I've got that, and this is what I get. That I have 2.13 times 10 to the 24 molecules in 600 grams. Okay, so that's how I would write out my answer. If you put that in there, like if you hit EXP and you put it, you get the times 10, and then you put in the hat, it's going to either give you a syntax error or it's going to multiply by 10 an extra time. So you won't have times 10 to the 23 in there, you'll have times 10 to the 24, and which means you're going to get an answer that's 10 to the 25, which is 10 times too big. Okay, all you need to do is hit the E button. Okay, once you have that, that's times 10, put in the power, close the brackets, you're done. Okay, don't put in anything extra. Okay. All right, does that one make a bit of sense? It's one extra step, multiplying by Avogadro's number. Okay, otherwise it's just like the first one we did. Cody. You don't need a TI-83. Okay, you can get a dollar store scientific calculator, okay, or a Wally World scientific calculator. Like you can get them for $5. Okay, you don't need to go out and buy a $180 calculator for science. They'll tell you something different in math, but in science you don't need that one. All right, and you can't use your phone obviously on a test. I collect them and put them in a bin on the test. So yeah, you do need to have a scientific calculator of some variety for next week. Okay, because I don't have any to lend out, and you definitely don't want to be doing your unit exam longhand. Okay, that would suck a lot. Okay. Especially, yes, doing these calculations or long division, okay, like, yeah. The mole equation looks simple until you got to do long division, right? Yeah, you don't want to do that. Okay. Fourth type of mole equation question. So make sure you write this one down. Okay. Also has the extra step in it, except this time it's backwards. Now they're telling us the number of molecules and want us to calculate the mass. So we're essentially going to do what we did in the last question in reverse. The last step will be the first step, okay? And we'll move backwards and calculate mass. All right, so what this question tells me is the number of molecules is 1.54 times 10 to the 25. And it tells me that this is diphosphorus tetraiodide. Okay, so phosphorus is 30.9897. 30.97. And there are two of them. Okay, and then I've got 4 iodines, and they're like 100 and something. 126.90 times 4. Okay, so we can get our molar mass here. So 30.97 times 2 plus 126.90 times 4. All right, so 569.54. It's a heavy one. Grams per mole. Okay, well, you got your first mark. You wrote down everything the question gave you. If I know the number of molecules, can I calculate the number of moles? Yes, because Avogadro's number tells me how many molecules are in a mole. So if I take how many I have and divide it by how many are in 1 mole, that should tell me how many moles I have. Okay, in the same way that if you go 48 donuts divided by 12, you get 4 dozen. Okay, I keep going back to this dozen thing because the Avogadro's number works just like a dozen does. Okay, it's always you calculate this number. All right, so we've got then to calculate n, we'll take the number of molecules, 1.54 times 10 to the 25, and divide it by Avogadro's number. Do I have more than a mole here? Yes, quite a bit more. All right, so how am I going to put this in my calculator? Do they both need to be in brackets? Yes, they do, both in their own set of brackets. Okay, so we'll have brackets 1.54, and then hit the E button. Okay, 25. Whoop, missed the 5. 5. Okay, and then divided by Avogadro's number, which also needs to be in brackets, 6.02 E 23. All right, so I have 25.58 moles. That's a lot. Okay, so I know the molar mass because I calculated that right off the bat, and now I know the number of moles. Can I calculate mass? Yes, I can. Now I go back to the mole equation. Okay, n equals little m over big M. I want to calculate little m. So I multiply both sides by big M, and I've got little m. So that'll be 25.58, my number of moles, multiplied by 569.54 grams per mole, the molar mass of diphosphorus tetraiodide. All right, so I have 14,569.63 grams. In other words, 14.5 kilos of this stuff. No, you should go to 2 decimal places. Yeah, show it all. Okay, so we would have 1, 4, 5, 6, 9, 0.63 grams. Okay, so exactly what we did in the third example, but totally in reverse. Okay, in that first one, we had to calculate the number of moles, and then we went back and used that to calculate the number of molecules. Okay, in this case, okay, we found the mass by going the exact opposite way. All right, those are the only 4 ways I can ask you a mole equation question. I can ask you to calculate number of moles. I can ask you to calculate mass. I can ask you to calculate the number of molecules, or I can give you the number of molecules and ask you to calculate mass. Those are the only 4 ways I can ask a mole equation question. Yeah. Yeah, yeah. They have to be enclosed in brackets. If you don't, what your calculator does is assumes everything is part of this exponent that comes after it, and that's the danger of it. It happens, but you'll know if you've done that because you will get an absolutely ridiculous number. Okay? So if that happens to you, don't write down the absolutely ridiculous number. Okay? Double check. Make sure that you've enclosed brackets, things like that. I tell my physics students this all the time. Okay? I say, make sure that your answer makes sense. All right, and I'll have a person tell me that the mass of this car was 500 grams. If they're calculating mass, I'm like, really? You thought I would make up a question with a car that weighed 500 grams? Okay, like this doesn't make sense. Always make sure your answer makes sense, especially on a test. I won't screw up. But once in a while on a worksheet, if I'm just pulling numbers out of my head, I might make one that doesn't make sense. But on an exam, never. Okay, the answers will be realistic and will make sense. So make sure that your answers are reasonable. Okay. All right, questions on those? All right. Now, got a couple of things here that I want to go through with you. Okay, just a couple of examples from each section here, and then I'm going to actually give you this worksheet. I think I have a copy for you. Okay. And then tomorrow I'll go through another 4 examples of the mole equation stuff here. Okay, told you I would do that every day for the rest of the unit. So, so question number 1 here. Okay, how many atoms or molecules are present in each of the following? Okay, I have 1 mole of gold. How many gold atoms do I have? Right. I have 6.02 times 10 to the 23 atoms of gold. Would the answer have been the same if it was silver? Oxygen? Okay, yeah. All right, so my answer there is 6.02 times 10 to the 23. You would be surprised how many people overthink that one. Okay, like I've put that as a multiple choice question on a test before and put just 3 numbers that made no sense whatsoever and had people pick them. Okay, don't overthink something is the lesson to be learned here. Okay, 1 mole is always this number. Okay, so if it's, what about 2.5 moles? 2.5 times Avogadro's number will give me how many molecules? Everybody follow there? Okay, so it like a lot of people really overthink a question like that. Okay, number 2, okay, is asking you to do a little bit of mole equation stuff here. So let's say 2A. How many moles are present in each of the following? What are you being asked to calculate? What part of the equation? N, right, number, okay? You're being asked to calculate N. So all of the ones in number 2 are N equals little m over big M. Okay, so we got 28 grams, okay, the mass they gave us, and it was sodium. So we just look up sodium on the periodic table. Okay, it's 22.99 grams per mole. Okay, and we do our calculation there. So okay, 1.22 what? Moles. Okay, it's calculating N, so it's moles. Okay, everybody following how these are working? Okay, they get a little bit more complex. I heard you laughing there because my calculator wasn't on. You think that's bad? I once did like a question that was 4 steps with it off. Just punching buttons, just looking at the buttons, the keypad, and no one. I start hearing chuckling after I've been at it for like 2 minutes. I look up. Yeah, it happens. Okay, let's have you guys get started on these ones here, and I will get you a copy of this for yourself. Okay, for number 4, they're telling us the number of atoms. Okay, so they're giving us the number of particles, and they're asking us to calculate the mass. This is like the last example we did. Okay, example number 4. I'm given the number of atoms and asked to calculate mass. If I know the number of atoms, and Avogadro's number tells me how many atoms are in 1 mole, can I use those 2 numbers together to get the number of moles? By dividing. Exactly. It's just like going 24 divided by 12 tells me I have 2 dozen. Okay? If I take the number I have, 3.01 times 10 to the 23, and divide it by Avogadro's number, I'll get the number of moles. Okay? So, to get N, I'm going to go 3.01 times 10 to the 23 divided by 6.02 times 10 to the 23. That's exactly half of that. Agreed? All right. So I have 0.5 moles. And it tells me it's copper. So I go to my periodic table. Okay, I look up copper. Copper's molar mass is 63.55. Sorry, I looked at that and then I looked away. 63.55. So big M is 63.55 grams per mole. Now I can calculate mass. N equals little m over big M. Multiply both sides by m. Okay, plug in the numbers, 63.55 times 0.5. Okay, and that should give us 31.78. That's, yeah, well, it didn't scan very well. But yeah, that's right, 31.78. All right, that ringing a bell. Okay, that's one of the 4 ways I told you I could ask a mole equation question. It's the longest one, okay, but it's going to come up. So number 6 is the question I warned you about earlier. Okay, it's all that question number 6 is asking is, do you know the difference between an atom and a molecule? Which is what I went over just a little while ago, right? A molecule is at least 2 or more atoms, whereas an atom is just a single particle. Okay, oxygen gas comes as a molecule, a pair of atoms. Okay, so what I'm going to do is solve this question like I'm calculating the number of molecules of oxygen in 64 grams. Okay, so I know that the mass I have is 64 grams. I know the molar mass of oxygen gas is 32 grams per mole. 16 times 2. Everybody follow me there? All right. If I calculate the number of moles now, because I can, okay, that's going to be little m over big M. That's going to be 64 over 32, which is 2 moles. Everyone all right with that? Okay, once I know the number of moles, and I have Avogadro's number, I can multiply those two numbers together and get the number of molecules of oxygen gas. Okay, moles times Avogadro's number gives me number of molecules. All right, so I'm going to take that and just go 2 times Avogadro's number, which would give me 1.20, what is it, 1.20 something. Never mind, we'll just do it. 6.02 times, turn on. Okay, 1.204 times 10 to the 24. All right, there's my number of oxygen molecules. Listening carefully here, guys. In every oxygen molecule, how many atoms are there? 2. What do I have to do with that number to get the number of atoms? Divide it by 2? Multiply it by 2. Right, okay? That's how many molecules of oxygen there are, and every molecule has 2 atoms in it. So I multiply that number by 2, and I've got the number of atoms. Okay? The alternate way to have done that would have been to use the mass of one oxygen atom, 16, and you would have got the right number right off the bat. Okay? Either way works. All right, so in walking around and in listening to your guys' conversations, the sense I'm getting is this. We don't know what all the things mean. Okay, that is, we don't know what N means, M means, big M means, or the 6.02 times 10 to the 23 means. Okay, because I'm seeing that kind of confusion happening out there. So quick review here. Okay, this number, Avogadro's number, is the number of particles in a mole. If I have 1 mole of gold, or if I have 1 mole of hydrogen, or I have 1 mole of cobalt, this is how many particles I have. Okay, is everybody clear there? Okay, this is the number of particles of anything in 1 mole. Okay, you use this number if you are trying to calculate the number of particles in a given number of moles, or if you are given the number of molecules and being asked to find the mass, then you would use this number as well. Okay, this number goes along this way. Number of moles equals number of molecules divided by this. Okay, that's the context in which you use Avogadro's number. Okay, if I want to calculate the number of molecules, then 6.02 comes over here and I multiply by it, just like we did in the first example in number 3. Okay, this is what we had to do in number 4, where we were given the number of molecules and then divided by Avogadro's number to get N. All right, everybody with me there? N is the number of moles. Okay, so in the mole equation, N equals little m over big M. That means number of moles equals mass okay. Number of moles is mass over molar mass. Okay, so when you come up to a question that says, how many moles of something are there, you're probably going to be using this. Okay, or if it asks you, what is the mass of this many, then you're going to use this, but manipulated for M. Okay, the first step is knowing what part of that formula am I supposed to be looking for. Okay, and that was the stumbling block I was seeing as we were going around, as people were like, mass, what's that? Mass is little m. Okay, that's something you just got to memorize. You got to know what the three parts of that formula mean. Okay. All right, so let's have a look at, let's say, 1D here first. Okay, so in 1D, I'm told I have 0.628 moles of carbon dioxide molecules. They want to know how many molecules I have. Okay, so this is how many moles I have. This is how many molecules are in 1 mole. What do I need to do with those two numbers? I need to times them. I need to multiply them. Okay, I have this many moles. This is the number in 1 mole. The number in 1 mole multiplied by the number of moles gives me the number of molecules. Okay, so I have 0.628 times 6.02. Whoop. Okay, and then remember that we got to enclose it in brackets, 6.02 E23. All right, 3.78 times 10 to the 23. Okay, everybody all right with that? All right, let's look at 2D. In number 2, I'm being asked to calculate the number of moles, which is N. Okay, they're telling me the mass and they're telling me the materials. So they're giving me little m and the ability to get big M. All right, so first thing I want to write down, what's big M? Sodium is 22.99. And what do I do next? If I want to calculate the molar mass of sodium chloride, I take the mass of sodium and add it to the mass of chlorine. Okay, that should be 58.44 grams per mole. All right, I have little m now because they gave it to me, and I calculated big M. Can I find N? Okay, so N is going to be 100 grams divided by 58.44. Little m over big M. All right, so 1.71. 1.71 what? Moles. Okay, everybody follow what I did there? Okay. In question number 3, what part of the mole equation am I being asked to find? Mass, which is which letter? Little m. All right, so let's look at 3A. I have 2.3 moles of nickel atoms. That means N is 2.3. It means big M is 58.69 grams per mole. All right, so N equals little m over big M, and I'm being asked to calculate little m. So I multiply both sides by big M, and I've got my formula. Now I plug in my numbers. Big M was 58.69, okay, and N was 2.3. All right, 134.99. What are my units? Grams. Okay, I'm solving for mass. My units have to be in grams. Okay, so just like the examples we did. Okay, if you wrote down your examples, refer back to them as you go through these and see, okay, which one is this like? All right, now I got to practice those steps. That's the whole idea here, is that we are recognizing that one of the 4 types of questions and practicing the steps for them. Okay. Avogadro's number is only used if you're being asked to calculate the number of molecules or you are given the number of molecules. That is the only time Avogadro's number comes in. Okay? If it's asking you about mass and things like that, you probably don't need it. Okay? Everybody with me there? Avogadro's number is only used when you're trying to find number of molecules or you're given the number of molecules. Okay? Then you'll use Avogadro's number. Otherwise, it's just a mole equation question. Okay?